First is generating the test configuration. Okay, so this generation include a description of a verification environment configuration and the duty configuration. Okay, so what they are trying to say is like how you are going to configure. Okay, how you're going to configure the verification environment as well as duty environment. Okay, so this generation also include a description of test case duration. Okay, so then they will talk about that how for how much time your test case need to be run. It is used for by self-checking structure to determine the appropriate response to expect, and by verification environment to configure the DUT. Okay, now they are trying to tell is self-checking structure. We should have a self-checking structure so that we can get an we can sample the from the we will take the response from the DUT, compare it with an expected environment expected result, and find the whether our result is right or not. So building the verification environment around the DUT according to the generated test case configuration. So test case will tell what type of environment you are going to create around the DUT. Okay, like which driver, whether you are going to take a PCI driver, whether you are going to take a AMBA driver, which driver you are going to take. So that thing also you have to assert during runtime. So the specific type and number of transactor that need to be instantiated around the DUT to exercise it correctly may depend upon the configuration that will be used. Like what they are trying to say is like when we are creating, we are now we are talking about the layer test bench approach, right? So in that, what all the things are there? Different layers are there, right? So at what time, how many interfaces should come? That also we need to be configured with the help of test case. Okay, you take example here. They are taking example. A DUT may be configured with the Intel style or a Motorola style processor interface. Okay, so there are two type of processor interface. One is having Intel style and one is having Motorola style. Okay, so each we have to give both the features in our BFMs. Okay, but which feature to enable, whether Intel style or whether a Motorola style. Okay, that we need to enable with the help of test case. Okay, each will require a different command layer transactor. Okay, because this also require different type of data, this require different type of data. So this command layer transactor, so which command layer transactor will come, that test case will decide. Okay, then disabling all the assertion and resetting the DUT. So this should this feature should also be available in your test case, that you need to disable the assertion at the beginning, and first you need to reset the device. So after resetting, configure the DUT according to the generated test case configuration. So what not test case will generate some random value at the top, like what all the fields it need to configure, right? So that test case will generate and it will configure the DUT. Okay, so this configuration may involve writing specific value to the register in the DUT or setting interface pins of a specific level. So means what they are configuring DUT means they are going to write something inside the register of the DUT. So that are control registers. Enabling assertions. So after configuring your DUT, you have to enable the assertions which you disabled at the third step. Okay, so you need to enable the assertion, starting all the transactor and generated in the environment. After enabling assertion, you are enabling the verification components that are transactor and generators in the environment. Okay, so what the transactor and generator should be started as soon as they are instantiated. So instantiated means when you are having a class and when you are creating a construct, means handle for that class, that is called as instantiation. So the DUT must first be configured to ready to correctly receive any stimulus. Okay, so that is what they are telling. First you need to configure the DUT, then you have to configure the BFM, because DUT should be ready, right, to receive the stimulus. So that is what they are trying to say. Starting the generator too soon complicates the response checking because the initial stimulus sequence must be ignored. Like now they are talking about the response checking. So response checking block is a verification component. Okay, so they are telling that if you are starting response checking, if you started response checking initially, means early, then in that case you may get your response checker will not work as properly, like what they are trying to say, because we need to ignore the initial stimulus sequences. Okay, because initially we are going to reset all those condition we need to perform at the beginning. Okay, after that we are going to send the sequence. Okay, so it will take some cycles. So that is what they are trying to say, response checking should be performed somewhat later. Okay, detecting end of test condition. Okay, this is also very important concept. Like when we are going to terminate the simulation. Okay, we need to identify one event. Okay, based on that event we should able to decide when to terminate the test case. Okay, that is what they are trying to say. So the end of the test case may be determined using combination of a condition. Okay, so many condition may be there. Depending on the DUT, a test case is terminated after running for a fixed amount of time or a number of clock cycle or a number of transaction until a certain number of error message have been issued when all the monitors are idle. So actually what is the conclusion, what is the summary of this is actually they're trying to say is like end of test case is possible with the help of DUT. Okay, based on DUT response we have to terminate the test case. So that may be a single response or that may be a combination of responses. So that is what they're trying to say. It will take many cycles or it will take a standard delay or it will take transactions, because that in terms of transaction, in terms of clock cycle or in terms of fixed amount they are terminating the test case. Stopping all generator in an orderly fashion. So after terminating the test case. Okay, actually here it should not terminate the test case. Okay, if it terminate the test case means I think we need to stop the test case here. Okay, after stopping the test case we need to stop all the generator in orderly fashion. Orderly fashion means first we have enabled which generator, first we are enabling test case. Okay, after that generator we are going to enable, then lower layer, that is driver, then monitor. So same way you have to disable those also. Draining the DUT and collecting statics. Okay, so to now what will DUT will exercise something and you will get a log file. Okay, so that log file you have to keep in separate folder and you need to find out the bugs. So what they are trying to say is to determine success of a simulation, it may necessitate to drain the DUT of any buffer data and download accounting of the statics registers. Okay, so they are taking the data from the DUT and performing that whether it is right or not. So any expected data left in the scoreboard is then assumed to have been lost. So if any data that is available, okay, in the scoreboard, that should you have to finish it, means you have to remove that thing. So what they are trying to say is actually they are cleaning the thing. So this is one sort of task that is going to clean all the registers. Then after that your test case need to report the failure or a success. Okay, so this is the single point answer, whether your test case is passed or your test case is failed.